Hello everyone. Today we are going to study the graphical method for the derivation of equations of motion. We have already studied 3 equations of motion in class 9 and the 4th equation of motion, which is very important for you to understand in 11th, is the distance traveled in nth second. So we will first write down all the 4 equations of motion and then after I will explain you what does it mean by the 4th equation of motion. First equation is v is equal to u plus at. Second is distance travelled in time t. So as is ut plus half at square. What is the third equation of motion? Third is v square is equal to u square plus 2as. And we have another equation of motion. The fourth equation of motion is distance travelled in nth second is equal to u plus a by 2 2n minus 1, right? And these equations of motion are for uniformly accelerated motion. So before we understand the fourth equation, we have to understand that for what case are these equations derived. So let's consider that your home is at the origin, right? And you start from your home to move in a straight line, because this is for a straight line motion, right? To move in a straight line, you reach a grocery store. Suppose this is your grocery store, right? Which is at a distance of x naught. That means you can say that x naught is the position of the grocery store with respect to your home. Then after at grocery store, suppose your speed is u, right? And the time you start measuring from the grocery store and you still have to continue your journey. Suppose you are continuing your journey towards a mall which is straight on this path only, and at this mall your position is x with respect to your home. You can say that this is the position of the mall with respect to your home, and x naught is the position of the grocery store with respect to your home. And at this mall, when you reach, the time is t, and since you had accelerated your vehicle and uniformly accelerated your vehicle, so the speed at the mall is v, right? And this is accelerated motion. Straight line with the speed is equal to velocity, so you can say the final velocity is v at time t, and initial velocity is u at time 0. That's why it is initial velocity, and this is a case of uniformly accelerated motion. So you can say that between grocery store and the mall, the distance travelled is x minus x naught, right? This can be written as s. S means the distance travelled between the grocery store and the mall in this case, or you can say from time 0 to time t, the distance travelled is s. So that means in this equation, u is the initial velocity when time t is 0, v is the final velocity when time is t, and a is the uniform acceleration during this journey. Similarly, s is the distance travelled, u is the initial velocity, and time t is the time elapsed for this distance to be travelled. Similarly, this case, now you have to understand what does this fourth equation of motion mean. So for understanding this, let's take an example, right? Suppose the distance travelled in 5 seconds is 10 meters, right? And suppose the distance travelled in 4 seconds is 8 meters, right? So from this case, this we are taking as an example to understand the case of fourth equation of motion. So that means when the 4th second ends, right, 5th starts, right? And we have to find the distance travelled in this 5th second. So fifth second means we have to find this distance, right? So what does that mean? That for this particular case, if distance traveled in 4 seconds is 8 meters and distance traveled in 5 seconds is 10 meters. So that means the distance traveled in fifth second, that means after the end of fourth second, in the last second, the distance traveled in this particular case is 2 meters, right? So hope you understood the difference, that here in this case distance in 5 seconds is 10 meters, but distance in fifth second is 2 meters. This is very important concept to understand, and I hope you understood this. So let's take the derivations one by one. Let's first take the derivation 1. Now for this derivation, we have already studied the graphs. So we must recall what these graphs are when we consider the velocity on the y-axis, right? And time on the x-axis, because time is an independent quantity and velocity is a dependent quantity, right? If we consider, you remember the figure which we had drawn, that at time t is equal to 0, the initial velocity is u. Let's again draw that. So when this is the time t is equal to 0, the initial velocity is u and initial position is x0. So this position is x0 from origin. Now from here to here, the acceleration is applicable and here time becomes t seconds, and during this interval, the new position is this. So this is x minus x0, that is the distance during this interval 0 to t. Right? We have already discussed this. So at time t is equal to 0, how much is the velocity? U. Right? And this is a uniformly accelerated motion. For uniform acceleration, just recall the concept. For uniform acceleration, the slope of VT graph is constant, right? So that means this is the position which is initial velocity, that is time t is equal to 0, and the slope of VT graph is constant. So that means our graph will be like this, right? Let's consider this as point A. This point as A, right? And another point B where the time elapsed is t, right? And at point B, the final velocity after time t is v at this point. So final velocity is v at this point. So we can say that according to this figure, at time t is equal to 0, initial velocity is u, and this point I am naming as A in the graph, right? And the time t elapsed point where the velocity is v, I am marking this point in the graph as B. So this corresponds to your point B in the graph. Now let's consider its derivation. Derivation is taken from this concept, that acceleration is equal to slope of the VT graph, right? So slope of the VT graph. So that means if I have to find the slope AB, how will I find the slope? The slope of AB is equal to V2 minus V1 upon T2 minus T1. We know that concept, right? So that means at point P, this position is V2, the final velocity is V, initial velocity is U, final time is T, and initial time is 0. right? So from here, by using the concept of slope, we are getting this equation because acceleration is the slope of AB. So from here, A can be equated to this part. So you can say that A into T is equal to V minus U. From here, V is equal to U plus AT. So this is our first equation of motion, right? Though you have already done this, right? So this is our first equation. Now let's move on to the second equation of motion. Second equation of motion is what? S is equal to ut plus half at square. So second equation, S is equal to ut plus half at square, right? Now we have to find the distance traveled during the interval 0 to t time, right? So in this interval, how to find the distance from velocity time graph, or you can say the displacement from velocity time graph? We know that the area enclosed between the VT graph and the time axis gives distance, right? So how to find the area? This area will be, therefore from the figure, area, if I mark this OAB and this point I am marking as C, right? So area OABC. Which geometrical figure is it? This one is a trapezium. So we know that for a trapezium, what is the formula? The formula for the area of a trapezium is half into sum of its parallel sides into distance between the parallel sides. Right? This is a symbol of parallel. Right? So from here, this gives us half. This area will be what? This will be distance. So I can directly write here distance is equal to half sum of parallel sides. Which two sides are parallel in this trapezium? This side and this side are parallel. So you can write down here that sum of parallel sides means AO plus BC. And distance between the parallel sides, these are the parallel sides. So this one is the distance between the parallel sides. So this is how much? This is T according to the graph. Right? So from here, this will be half. How much is AO? AO is U according to the graph. So this is U. How much is BC? BC is V. This is equal to this one. So this is V and this is T as it is. Right? Now from the equation, first equation of motion, we know that V is equal to, since first equation of motion is V is equal to U plus AT. Now in second equation of motion, what do we need to eliminate? In our equation of motion, we don't have V. So we need to eliminate final velocity, right? So final velocity can be eliminated like this from here. So we can directly put this value for V in this equation. So from first equation of motion, half U plus, for V we are replacing u plus at. U plus at multiplied by t. So this makes it half 2u plus at into t. So what does it give? It gives I'm rubbing this. So from here to here, this s is equal to half 2u plus at into t. So this gives us u plus half at square, because this t is multiplied here, 2 cancel, so this makes it ut, and if I multiply this half here, t here, so this makes it half at square. So the equation of motion is s is equal to ut plus half at square. This is what our second equation of motion is. Let's move on to the third equation of motion. Right? For third equation of motion, the initial steps will be exactly same up to here. So the initial steps will be same, but we have to check that what do we need to eliminate from this equation to get the third equation of motion. This is our third equation of motion. Now from here, we know that in our third equation of motion, time is not there. Now how can time be removed from here? We know that in this graph, the slope of vt gives acceleration, right? So we can say that acceleration is v minus u upon t, as we had done in equation 1, right? So from here, I can replace t is equal to v minus u upon a, right? So this, let's mark this as equation 1 and this as equation 2. And then after we will move on to this step, right? So put 2 in 1, right? So from here s is equal to half u plus v, and for t we will write down v minus u upon a, right? This is a plus b, this is a minus b. So this can be written as half a minus b to a plus b is a square minus b square, and a remains as it is. So this becomes our third equation of motion. 2as is equal to v square minus u square, or v square is equal to u square plus 2as. This is our third equation of motion. Let's move on to the last equation of motion, which I had explained, that is the distance traveled in nth second. So let's derive that also by this method. Now in this case, let's consider a position where time is n seconds and n minus 1 second. Suppose this is n seconds time and this is n minus 1 seconds time, right? Because we have to find out the distance traveled in nth second. That's our fourth equation, right? Which we have to derive now. So what is that equation? Distance traveled in nth second is equal to u plus a by 2 to n minus 1, right? So from here, I hope you are getting this equation, right? We have to find this position and this position. This position is corresponding to your time L minus 1 seconds, right? So n minus 1 seconds, this position is, suppose A in this graph, and at n seconds, the position is B. And we have to find the distance traveled in nth second, right? So that means we have to find this area, first thing. Second thing, if time is n minus 1, this speed is the final velocity at n minus 1, right? And at n seconds, it becomes Vn, right? From here again, since we have to find the distance traveled in nth second, this is distance traveled in nth second, right? So distance in nth second again is calculated by the area. Let's mark this point as C and this point as D. So area ABCD is equal to distance in nth second, because here n minus 1 second is complete and nth second starts, just as in case of 4 seconds complete and 5th second starts, right? So here distance in nth is half, because this is a trapezium. This is trapezium, so this is half. Sum of parallel sides multiplied by distance between them, right? So this gives us distance in nth second is equal to half. Sum of parallel sides means this side and this side. So this side is Vn minus 1 and this side is Vn. Distance between them is n minus 1. This complete is n. This is n minus 1. So this separation, we need this separation. And this will be n minus 1. Right? Now from here, from first equation, V is equal to U plus AT. Right? So here initial time is n minus 1, right? And final time is n. So we have to find for this case. So here in this case, V will be what? V will be velocity at n minus 1 second is equal to U plus A into velocity at into time n minus 1. Right? So similarly for t is equal to n seconds, right? So at n seconds, how much is the velocity? Vn. Initial velocity for the whole journey will remain the same, U. So this is U plus, for A, this is uniformly accelerated motion, so A will also remain same, and time here is n, right? So from here, if we put the values in this equation, this can also be simplified here, half Vn minus 1 plus Vn. So n minus n plus 1, so this makes it 1. N minus 1 is cancelled, so I will completely write this n minus n plus 1. So this is cancelled here. So let's mark this as equation 1 and this as 2 and this as 3. Let's put the values from 2 and 3 in 1. So I'm rubbing this part here. From 2 and 3 in 1, right? So as nth is equal to half. We are putting the value of Vn minus 1 from 2. So this is U plus A into n minus 1. So this value we have replaced for Vn minus 1, and then we have to write for Vn, this is U plus A n, right? That's what we have to write. Rest is 1 over here. So this is S and F is equal to half, right? U plus A n minus A plus U plus A n, right? From here on solving, this is S and F is equal to half, and inside this U and U are added, 2U plus 2AN minus A, right? So let's solve this. This is U plus, multiply this also by, so this gives us AN. If I take this LCM, so this makes it 2n minus 1. Why so? I can explain it here. U plus A common and minus 1 by 2 here. So this gives us U plus A. I can take LCM here, 2n minus 1. So this gives us A by 2, 2n minus 1. This is the distance travelled in nth second. Though the first three equations, when these are derived by graphical method, these are more important, but even this can be derived by using graphical method. That's why we have done this also. That's all for now. Thanks.